Dear students, a very good morning to all of you. Today we discuss about dipole kept in uniform electric field. In previous three videos, we talk about and we learn what is dipole moment, and electric field due to a dipole on the axis of dipole, on the equatorial of a dipole, and for any general point we find out electric field intensity due to a dipole. whenever we uh, Whenever we put a dipole in kept in electric uniform electric field, it experience a force. How much this force and how we can calculate this force? So we already know, for a point charge in electric field experience a force, that is QE. Here we have plus due to charge plus q, this is force experiences plus QE, and another charge we have minus q, this experience of forces minus QE. The direction of electric field is in this direction, so force experienced is in this directions, and due to minus charge force experienced in this directions. That means we have a field is uniform, so these two forces are equal in magnitude but opposite in directions. Then net force is plus QE and minus QE is equal to 0. What do you mean by this net force is equal to 0? This net force is equal to 0 means dipole do not have any linear motions. Another thing, we find out what is the torque. Why we find out torque? Because we know that torque is a quantity, or we can say we can define torque is a constitute of couple of forces. Which type of couple of forces? That is equal and opposite and certain distance between them. Then we find out net torque. So how we can find out net torque? For torque is equal to force into perpendicular distance. Here we have perpendicular distance is, this is the perpendicular distance. Electric field is in this directions, these two charges, or we can say make this arrangement is dipole. Perpendicular BC, how much this distance? We find out easily from figure. BC upon 2L, that is equal to, BC is perpendicular and 2L is hypotenuse, that is equal to sine theta. So BC is equal to 2L sine theta. Torque is equal to force into perpendicular distance, or so we have force is equal to QE multiplied by BC, and we find out BC is equal to 2L sine theta. We put the value BC here, so we have Q into 2L into E sine theta, and we know that Q into 2L, what is this? This is dipole moment, so we have torque is equal to P sine theta. We know that dipole moment is vector quantity, electric field intensity is vector quantity, so torque is always a vector quantity. So torque is cross product of dipole moment and electric field intensity. Another topic we discuss, work done in rotating a dipole. How much the work done when a dipole is rotated? Here we have a dipole is minus q and plus q, having a certain distance between them. So this arrangement is a dipole, and electric field is in this directions, and it makes an angle theta. A dipole makes an angle theta from the electric field directions. So we know that work is equal to force into displacement. Here we have displacement is x, and work is equal to force into displacement. We dividing and multiplying by r, so W is equal to force into distance multiplied by x upon r, and this R is perpendicular distance. This R is perpendicular distance, and so we can write as W is equal to torque multiplied by x upon r, where we have x upon r is theta, where we know that theta is equal to arc upon radius. So we can write as W is equal to torque into theta. How we can calculate how much the work done in rotating a dipole? We know that W is equal to torque into theta. So dW is equal to torque into d theta for a very small angle. Integrating both sides, because integrations means summations. W is equal to theta 1 to theta 2. We integrate work done from theta 1 to theta 2. We know that torque is equal to P sine theta and d theta. We taking out common PE. Common so is not appropriate word, because these two quantity are constant quantities. P is dipole moment, E is electric field intensity. These two physical quantities are free from the theta, so PE, taking out PE, and we know the integration of sine theta is minus cos theta, integrating from theta 1 to theta 2. So we have Pe cos theta 2 minus cos theta 1 and Pe cos theta 1 minus cos theta 2. We taking theta 1 is equal to 0 and theta 2 is equal to theta. So we put the value of theta 1 is equal to 0. So we have W is equal to Pe cos theta 1, that is equal to 0. So cos 0 is equal to 1. So we have formula W is equal to Pe into 1 minus cos theta. This is general expression. For any values, or we can say for any theta's value, we find out the work done in rotating a dipole. This is the last topic for a dipole, and in next videos we talk about what is Gauss theorem or electric field flux. These things we discussing. Thank you.